All right, so we're going to take a look at the second day of 4.7. This is where we're still solving, but we've got just a little bit more work to do to get our equations equal to 0. So number 19, I start by distributing my 6x. So I get 6x plus 72 equals x squared. Like I said in class, since I prefer to have my lead term positive, I'm going to go ahead and subtract the 6x and the 72. And now that my values are equal to 0, I can start factoring. And I know that I've got factors of negative 72 that are negative 12 and 6 that will add back together to be negative 6. So I finish my factoring, set each piece equal to 0, and then come up with my final answer. Again, don't forget to write or. Whether you write it as x equals 12 or x equals negative 6 is up to you, but make sure you include the word or. Number 20, I've got to go ahead and distribute it on my left-hand side again, but that distribution is going to involve more work since I'm distributing u plus 3. Now, I think it's a little bit more clear why I always took this approach, because it was building towards what we were doing in factoring. But again, if you prefer to use FOIL, that's fine. So I finish my multiplication. I'm going to move my 8u by subtracting it. I write my function in descending order. My factors of negative 9 that are going to add back together to be negative 8 are negative 9 and positive 1. So I finish my factoring, set each piece equal to 0, and solve. And again, do not forget to use the word or. (21), like we saw in our quiz, is probably the most commonly mistaken problem because people forget to write the y minus 4 twice and then do their distribution. Keep an eye out for that on this week's quiz. Make sure that you don't make that careless mistake of forgetting to multiply it out correctly. Once I've finished my multiplication, I just need to subtract my 2y from both sides, combining with my like term negative 8y. And now I look for factors of negative 16 that are going to add up to, positive 16 that are going to add up to negative 10, and that's negative 8 and negative 2. So I finish my factoring, set each piece equal to 0, and finish my solving. (22), just like 21, I've got to remember to write x minus 6 twice, not just distribute that square. That's not how it works when we've got addition or subtraction. I set up my multiplication. Again, whether you use my method or use the FOIL method, it's fine with me. Once I finish my multiplication, I need to get my equation equal to 0, so I'm going to subtract x on both sides, and now I'm ready to try and factor. Factors of positive 36 that are going to add up to negative 13, negative 9, and negative 4. So I finish my factoring, set each piece equal to 0, and I have my values. And once again, don't forget about the word or. (23), I see that I need to distribute the 3t on the left-hand side of my equal sign, the 4 on the right-hand side of my equal sign, and then I can start solving. Again, since I prefer my lead term to be positive, I'm going to subtract the 4t and the 4, from both sides. Since my lead coefficient isn't 1, I've got to start my process of splitting the middle term, multiply the first value times the last value, and then I look for factors of negative 12t squared that are going to add up to negative t. That's negative 4 and 3. Split my middle term, form my groups. For my first group, I can take a t out. For my second group, I can take 1. Notice that I've got 3t minus 4 as my matching value. So I factor 3t minus 4 out, leave me with t plus 1. Set each piece equal to 0. Going to have to do a little bit more work on the left-hand side here to finish solving. Add 4 to both sides, divide by 3 on both sides. And I've got my answer. (24), I'll distribute my 2 to the r squared plus 1. I'm going to subtract the 5r from both sides. Again, I don't have a lead coefficient of 1, so I'm going to start my process of splitting the middle term, multiplying my first term times my last. And then I need my factors of positive 4r squared that are going to add up to negative 5r. I split my middle term, form my groups. From the first group, I can take out a 2r. From the second group, I can take out a negative 1. Again, these two sides will always match. r minus 2 matches its in both pieces. So I've got r minus 2 times 2r minus 1. Set each of those equal to 0, and solve. Pardon me. Now, 29 is something that we would call quadratic in form because our lead degree is twice our middle degree. So when I factor, instead of ending up with x's inside my binomials, in this case I'll end up with x squareds. Factors of -1 that are going to add up, factors of 1 that are going to add up to -2 are -1 and 1. So I factor, but then I check and see, can I factor these groups? Since these are matching, I only have to look at this factoring once, and I see that I've got a difference of squares. So my x squared minus 1 and my other x squared minus 1. I can see that I've got repeating groups, which means I'm going to have double roots. And so instead of solving all 4 pieces, I just solve the 2 matching pieces, and I come up with my value. And again, they are double roots. 30, look for my factors of 4 that add up to -5. Again, I can see that I've got something to the 4th power and squared. So when I set up my group, I'll have y squared and y squared. Now, once I've written my y squared minus 4 and my y squared minus 1, I've got another difference of squares, so I'm able to continue factoring. And unlike the last one, I do have 4 separate values, so I'll set each of them equal to 0, and I end up with 4 separate answers. All right, so that's the end of today's homework. If you still have any questions, feel free to ask when we're back in class. Hope this helped, and if not, again, please ask questions.